So, you're ready to do some limit problems. Okay, let's try it. Now, what we're going to do is take the limit of something. Let's take the limit as x approaches to f of x. And I'm going to define f of x as to be x squared plus 2x plus 2 plus 3x squared plus 4x cubed plus 12x to the fourth power minus, let me put that minus there, 6x to the fifth power. Let me rearrange this. So f of x is equal to negative 6x fifth plus 12x to the fourth plus, if we combine the 3x squared and also the x squared, it becomes, actually before 4x cubed plus, let me separate this, x squared, 3x squared, 4x squared plus 2x plus 2, 2x plus 2. So we just plug in 2 and get this result. So f of 2 is equal to, let me give you a second here to do the problem. Got it? Got it. Negative 6 times 2 to the fifth power plus 2 to the fourth power plus 4 times 2 to the third power plus 4 times 2 to the second power plus 2 times 2 plus 2, which is equal to, what is 2 to the fifth power? You can do it out, or you might have it memorized. Negative 6 times 32 plus 12 times 2 to the fourth, 16, plus 4 times 2 to the third, 8, plus 4 times 2 squared, 4, plus 2 times 2 plus 2, which is equal to negative 6 times 32 is of course equal to negative 192, and 12 times 16 is equal to 192. Similarities. And 4 times 8 is 32. 4 times 4 is 16. 2 times 2 is 4 plus 2. Equals to, these two cancel out. 32 plus 16 is 48, plus 4 is 52, plus 2 is 54. So this limit, so the limit as x approaches to of f of x is equal to 54. That's our answer. Now, let's do another problem. Now we're going to use some of our trigonometric functions, and this is going to be in radians, so beware. So the limit as x approaches pi of cosine of x over the sine of x times the cosecant of x. What is that? Well, we could simplify this. Cosine of x over the sine of x is equal to the cotangent of x. So this is equal to the limit as x approaches pi of the cotangent of x times the cosecant of x. This is a simplified version. If we spread out this cosecant, we could break that instead of 1 over sine of x. Sine of x at pi is equal to 1. Sine of x at pi, 0. That's whole thing. Cotangent times cosecant as x approaches pi is equal to 0. Then you might ask, because we know how to do all these trigonometric functions, what is the limit as x approaches pi of tangent of x? Well, we could break that into sine of x over the cosine of x, because tangent is literally just the slope of the line, so that's tangent inside the unit circle definitions anyways. And that thing as approach to pi is sine of pi over the cosine of pi. And we struck a problem. Cosine of pi is equal to 0. How do we do this problem? The answer is this limit doesn't exist. We can't define this limit to be anything. Well, there's a general notation for the limit as a approaches some value b from the positive or the negative side of some function f of x. And this can be useful, but I'm going to explain that next video, so keep out. Remember this, and remember that tangent of x is not defined. Let's try it next time. Bye bye.